Continuing, talking about 3D printer workflow and software. So as we work with our 3D printers, we went and we calibrated the levelness of the print bed, and we're looking at some of the errors that can happen as we work with our 3D prints. In chapter 3 of our readings, we go through 3D printer workflow and software. And so we're working on the design aspect. We're working with different CAD softwares to generate our models. And then we're working with the slicing software. And we have two right now. We have the Dremel software, and the Dremel software is specific to the 3D45 3D printers that we use here. And we're working with a number of these different settings that are in here. And in the textbook reading, in this chapter, we'll talk about the infill, and we'll also talk about print quality, and we'll also talk about build plate adhesion. Returning. So there's a number of areas that we want to become familiar with tying these design, slicing, and then printing, or it's actually running these G-code CNC type machines, additive manufacturing machines. It's not really fair to call them 3D printers. They're really additive manufacturing. And so we looked at types of models that we can get and where we can get them. It also goes through mesh repair, and again, where we can get some of these different models. And so, for example, one of the models that I really like to work with is through Thingiverse. Let me see if I have it. Yeah. So here's Thingiverse. Halloween is coming up. So I've had people who want to make Halloween costumes and things like that. And some of the aspects are really pretty good that they start to teach us. Like, this is sort of a thing that I'll have students want to create. I had one student who was in my class who wanted a Master Chief helmet. And he actually came in on Halloween dressed as Master Chief. I think that's his name from Halo. I should know this. We have all the games at my house. But as you'll notice, they print it in sections. And so that's the technique. You have to post-process them, or you print them in sections, and then you have to do assembly and things like finishing, okay? By using sander sealer, which is like a primer that you spray out of a can. You can smooth out the outer shell of it and then be able to apply paint and have some really good applications for it. So Thingiverse has a number of models that we can go and we can retrieve that are created by other designers. And some of the things that we're going to look at will be things like dual head. So if we dual head extrusion. So if we say, and let me make sure I'm in the right one, search Thingiverse, not the internet. I'm just going to say dual printing. And I can look at some dual printing applications. Not my best hit as far as my, let's try dual extrusion. That's a better one. This is the tree frog that I created on the, or that I modeled on the Ultimaker. The Ultimaker also has a number of tutorials, and I'm looking at how to work with that. They changed their website, but Ultimaker had all of this awesome applications that you can get into, and they're very into education. So feel free to go to the ultimaker.com website and to look for some of these other resources for working with 3D printing, because that's really how you do it. You find the information on YouTube and on the internet now. As we continue working on this assignment, let's go back and look at our reading. So we can get these CAD models from a number of different repositories, and then we can search for specific aspects. And what we want to do is look at some of the troubleshooting. And so let's go down. I'm going to make this a little bigger so I can go faster. And so they do talk about these slicing programs. And so right now we're using the Dremel 3D 45 slicing software in the Cura software. Cura has a ton of support. And so I recommend you go and you look at the Cura support page. We're in the simulation of our 3D print. And then we're looking at print quality and layer height. So as we're working with these different models, if we're getting some failures with it, maybe we need to adjust our print quality. Another thing that we want to look at as we go through is something called platform adhesion. Bring this up a little bit. Whoops. So print quality and layer height, as we work with print quality and layer height, they have some rules, and these are the things that we want to start to study. Layer height, it has to be less than or equal to the nozzle diameter. About 80% of the nozzle diameter is a good maximum value for layer height. So we can go through and we can Google what is my nozzle diameter on a 3D 45, and we can come up with that calculation. I'm not going to go into that on the fly at this time, but we'll keep that in mind as a rule of thumb, because just like working in the machine shop with CNC machines, cutting metal, we're kind of applying that type of process in reverse now, where instead of removing material, we're adding material, and nozzle heights and extrusion become issues, especially when we're printing a lot of things. We'll also look at some other issues with shells. This is something that we'll come back to. Build plate adhesion is what I want to talk about right now. And so as we're looking at build plate, they're talking about some of the errors that can happen. And so when the print fails, you'll get sort of a bird nest in the printer. And so some of the causes and some of the things that we can look at within that, things like brims. So as we work with our software, the build plate adhesion here, I have this one set for brim. And as we come in here and we look at it, we can then adjust the brim width. And so instead of 8 millimeters, I could say, let's go with 4. And then what we would do is we would re-prepare that. And then it'll go through and create a smaller brim. I'm going to go back to 8 with that. And what we want to avoid is that part coming off of the build plate. And sure, I'm just doing one today, but let's say that the school wants 200 of these. It's not a high volume production. It's perfect for 3D printing. If we were to print these or make these in other traditional manufacturing techniques, they would build a mold, and they want 10,000 at least as an initial print job. Switching back over, bridging is the distance that you can print something. You can see there's a little bit of a sag here, but it still holds together. In other words, the layers still attach one to the other. And these are tests that you can go through, and you can print out these different models. They have this tugboat that they'll typically print on Thingiverse that people will use to calibrate their printers, and we'll look at that. Continuing on, we can also look at rafts. And so as we look at bigger builds, we were making clock faces, and the clock faces were about 5 inches by 5 inches. They're big and they're flat, and they're not really thick. As we made these, we did them for a kid's summer camp. I can show you some of those models when I'm not in the recording. We had a lot of the prints lifting off. And so again, if you're having a big build that's going to take 6 hours or so, make sure the build plate adhesion is super good. And so I can go to a raft, which will add to my build time, but you'll see in here, now it's really going to stick to that build plate. Some of the things you do need to be concerned with is whether you max out or you build beyond the build plate's ability to hold the machine or to hold the part within the machine. You can see we've also adjusted the infill pattern. And so here's our build plate. We have it set up as a raft. And then we can also look at some of these other things like the spacing and things like just some small adjustments. I'm going to change the infill pattern. And we're going to go with, let's go with tetrahedral. Let me prepare that. And then you can see, again, we have these different build plate patterns. And if you start using some of these semi-transparent materials, you can get some really cool backlighting effects. And so if I'm going to light this on a glass table, or if I'm going to use this to display, let's say I have a laser engraved piece of crystal, I could put an LED light in the bottom of this and then mount the crystal and use these as a platform to display my art. Switching back, as we look at the rafts and things, more on build plate adhesion and some work with support. And so as we work with support, the orientation of the part is also important. We want to make sure that as we orientate it on the machine, let's say we wanted to change this, we could say rotate, and then we can go and grab the Z-axis hoop and spin that 90 degrees and then re-slice it. And what you'll see now is there's a lot more support material required, and it also increases our build time. Some parts, depending on what we're printing, do have to be in these different orientations. One technique that we will do when we work with these is oftentimes we'll print them on the glass side in reverse because it's a nice, smooth first layer. And so when we print certain things like coasters, we'll prepare them so that the part that is printed first is on the build plate. We have a nice, clean, quality aspect to our build. You can see here's a model that was printed in this manner. And so if we work with some of these semi-transparent materials and we do something called the lithoplane, they'll be printed in a vertical orientation. All right, so we talked about bridging. And we talked a little bit about infill. Here's some other applications for our typical patterns that you're welcome to work with. And then as we go through, we're working more with techniques to go through and continue to maintain our quality as we start to work with some of these build errors. All right. At this point, I think that's a good stopping off point. We'll continue on looking at some of the other applications that we can look at fixing the problems with our 3D printers. I'm going to stop this recording, and then we're going to talk a little bit about our assignments, and then I'll let everybody get back to work.